In this video, we are going to be looking at the gradient of a line. Now, the first thing I would like you to know is that another name for gradient, another name for gradient is slope. So anytime you see slope, it's the same as gradient. Now, the next thing I want you to note is that every line has an equation. Now, this is the general equation. We have y equals to mx plus c, general equation for a line. Now, where this m here as the gradient or the slope, then c is known as the y-intercept. Now, for this to make perfect sense, I want you to understand that in this context, when we are talking about line, we are talking about it in relation to a graph. Now, to really understand what we mean by gradient of a line, I need to show you what it means in context of a graph. Let's do this. All right, so here's a graph. Definitely, you can see the graph below here. Now, on a graph, a line is not just a line from anywhere just placed on the graph. Actually, a line graph is gotten when we plot something against another thing. Now, in a real life situation, if we have a vehicle and this vehicle has a distance it's covering at a specific time. Now, I have a table here. Now, let's say this is the distance on top. And so the car covers 2 probably meters in one, maybe second, and then it covers 4 meters in 2 seconds, 6 meters in 3 seconds, 8 meters in 4 seconds. Now we can plot this on a graph, and when we plot this on a graph, we have a straight line graph. Let's try to do that. So this is a graph here. Let's say on this y-axis we have the distance, and then on the x-axis we have the time. Now for the distance, 2 corresponds to 1, so we have this point here. 4 corresponds to 2, so we have this point here. And then we have 6 corresponding to 3, so we have this point here. Then we have 8 corresponding to 4, so we have this point here. Now you can see that this here is a straight line. Do you understand what I mean? So a straight line does not just come from nowhere. It's actually we are plotting something against something. Now, let's now go to the topic for today, slope. Now, the real meaning of slope in maths is actually rise over run of a straight line graph. Rise over run. Now, what that means is that you can see this graph. We have the height, which is the rise, and then we have the breadth, which is the run. So if I'm told to calculate the slope of this line, all I need to do is to try to form a triangle. So I can have any triangle. You can form a triangle from any part of the line. All right, so now remember we are doing rise over run. So I'm trying to find the rise over the run. Now let's try to find the rise. How many steps did it rise? So we have 1, 2, 3, 4, 5, 6. So the rise is 6 over how many times is the spread? Did it move to the right or to the left? So we have 1, 2, 3. So 6 over 3. Now 6 over 3 is 2. That means the slope of this line graph is 2. Now in the real life situation, the slope of a distance time graph gives us the speed. I don't know if you understand that. So when we have the slope of a distance time graph, we have the speed. Do you see that slope is actually something that can be related to our daily life? Now, for example, if you are a science student and you've done speed in physics, you know that the formula for speed is actually distance over time. So if we try to calculate any of the speed of the variables we have in this table, let's pick 4 and 2 for example. It means that the speed will give me 4 over 2, which is 2 meters per second. Can you see that that's what we got in the slope 2? So for a distance time graph, the slope is actually the speed. Now, do you understand that? Now, let's solve some examples, but now using the number formula you will get in school. But all I need you to know is that in the real world, slope can be related to our daily lives. And it's important even to us as human beings. Let's do some examples. Calculate the gradient of the coordinate points A 1, 2 and B 4, 8. Now, before we do this, I need to tell you what the formula for calculating gradients is. Now, gradients equals to, remember I told you that it's rise over run. Now, rise is actually the y-axis because it's like up. So the y-axis. So we have y2 minus y1 over run x2 minus x1. This here is the formula for calculating gradients. y2 minus y1 over x2 minus x1. Now, having said this, let's calculate the gradient of these points. Now, the first thing you want to do is to label the coordinate points x and y. So we have x1, y1, x2, y2. So our solution, gradient equals to y2 minus y1 over x2 minus x1. Now, gradient equals to, what is y2? y2 is 8. So I put 8 minus y1 is 2 all over, what's x2? x2 is 4 and x1 is 1. Let me complete it here. So it means gradient equals to 8 minus 2 is 6. 4 minus 1 is 3. So gradient equals to 2. So the answer is 2. I hope you understand this. Let's take another example. Calculate the gradient of the coordinate points A minus 1, minus 3 and B 3, 6. Now let's do this. Remember, the first thing you want to do is to label the coordinate points x1, y1. Then we have x2, y2. The next thing is to write the formula. So gradient equals to rise over run. So we have y2 minus y1 over x2 minus x1. Now gradient equals to, what is our y2? 6. y1 is what? Minus 3. So I have to put that in brackets. All over x2 is what? 3. Minus x1 is what? Minus 1. I have to put it in brackets too. So which means gradient equals to, minus times minus is plus. So I should have 6 plus 3 all over. Minus times minus is plus. So I have 3 plus 1. Let's complete it here. So we have gradient equals 6 plus 3 is what? 9 all over 3 plus 1 is 4. So this cannot cancel one another. So we can say gradient equals to 9 over 4. I hope you understand this. Let's take another example. Calculate the gradient of the coordinate points A minus 2, 2 and B 2, minus 2. Remember, the first thing is to label x1, y1, x2, y2. The next thing is to write the formula. Can you remember the formula? Gradient equals to rise over run. So we have y2 minus y1 all over x2 minus x1. Which means gradient equals to, our y2 is what? Minus 2 minus our y1 is 2 all over our x2 is 2 minus our x1 is minus 2. So I have to put it in brackets. Is that clear? So we have gradient equals to minus 2 minus 2 is minus 4 all over, this would give me 2 minus times minus is plus. So I have 2 plus 2, 4. Let me solve the remaining here. So I will be having gradient equals to minus 4 over 2 plus 2 is 4. So which means gradient equals minus 1. Is this not super simple? Now there's one more thing I need to tell you before we take exercises. Now let's say I have got a graph. Let me just try to draw one. Alright, say on this graph I've got a vertical line. Now remember, this line is a vertical line. So I need to mention that it is a vertical line. A line like this is a vertical line. Now the question I want to ask is, what is the slope of a vertical line? What is the slope of a vertical line? Now, as you can see, a vertical line only has rise. It does not have runs. So what that means is that for the runs, we'll be having 0 beneath. It only has rise. So which means that the slope of a vertical line is undefined. Now the reason for this is any time you have 0 as the denominator, we say that fraction is undefined. For example, 4 over 0 is undefined. So if you do this on your calculator, it will be telling you math error. 2 over 0 is undefined. Now, because a vertical line does not have runs, it means that the slope of a vertical line is undefined. Now, you want to ask yourself, what is the slope of an horizontal line? So we have an horizontal line. Now, remember, an horizontal line does not have rise. It only has runs. So it means 0 would be on top. Remember, slope or gradient is rise over runs. So an horizontal line does not have rise, so we have 0 on top, and then we have runs beneath. Now 0 over anything equals to 0, which means that the slope of an horizontal line equals 0. Now don't forget that the slope of a vertical line is undefined, and the slope of an horizontal line equals 0. I hope you understand what I taught you today. If you do, let's take an exercise.